Welcome back to Cosmic Compass, the channel where we explore the wonders of the universe, one story at a time. From distant galaxies to the icy moons of our own solar system, we uncover the science, the mysteries, and the beauty that lie beyond Earth. Today, let's turn our gaze to Saturn's tiny moon, Enceladus. At first, it looks like nothing more than a frozen snowball drifting through space. But as we'll discover, this little world may hold one of the most exciting secrets in the entire solar system, a hidden ocean that could potentially harbour life. Imagine standing on a frozen world no larger than England, where beneath your feet lies an ocean deeper than anything on Earth, and above you icy geysers launch jets of water straight into space. This is Enceladus, one of Saturn's many moons, and yet one of the most fascinating objects in the entire solar system. At first glance, it looks unremarkable, a tiny white sphere, the sixth largest of Saturn's moons. But as we will soon discover, appearances can be deceiving. Enceladus hides extraordinary secrets beneath its icy shell. Thanks to the Cassini mission, we've learned more about Enceladus than perhaps any other moon of Saturn, and yet many of its mysteries remain locked away. Today, let's journey together to uncover the story of this small but powerful world. To understand Enceladus, we must first place it in context. Saturn has over 80 confirmed moons, and Enceladus is currently its 14th closest. That might sound insignificant, but among Saturn's larger moons, it's the second closest, trailing only behind Mimas, the so-called Death Star moon. Enceladus orbits just outside Saturn's major rings, circling the planet once every 33 hours. Its path follows the ring plane almost perfectly. What's more, it is locked in a 2-to-1 orbital resonance with another moon, Dione. In the time Dione completes one orbit, Enceladus circles Saturn twice. This orbital relationship is important. It prevents Enceladus's orbit from becoming perfectly circular. Instead, it remains slightly elliptical, causing the moon to stretch and compress under Saturn's immense gravity. This process, known as tidal deformation, generates heat deep within Enceladus's interior. Without this mechanism, Enceladus would be a frozen, lifeless rock. From the outside, Enceladus looks like a snowball drifting through space. Its surface is made almost entirely of clean water ice, with little to no rock mixed in. This makes it one of the brightest objects in the solar system, reflecting over 80% of the sunlight it receives. But brightness comes at a cost. That reflective surface prevents Enceladus from absorbing much heat, leaving it among the coldest places in Saturn's system. Midday temperatures hover around -200 degrees Celsius. And yet beneath that frozen crust lies something astonishing. About 30 to 40 kilometers below, the combination of tidal heating and internal pressure has melted parts of the ice into liquid water. Scientists suspect that this is not just a local reservoir, but possibly a global ocean stretching beneath the entire surface of the moon. If true, Enceladus would be a genuine ocean world, similar in concept to Earth, only with ice instead of rock forming the crust. Just as our continents float above a mantle of molten rock, Enceladus's icy shell may float above a hidden ocean. So how do we know this ocean exists? The clearest evidence comes from the spectacular plumes erupting from Enceladus's south pole. These geysers eject water vapor and ice particles into space at incredible speeds, over 2,000 kilometers per hour. Every second, about 250 kilograms of material is blasted out, enough to fill dozens of bathtubs in a single heartbeat. Much of this material escapes the moon's weak gravity and goes on to form Saturn's diffuse E-ring, a vast halo of icy particles stretching thousands of kilometers across space. When sunlight passes through the ring, glows an intense blue, making it the bluest object in the entire solar system, even more so than Neptune itself. Enceladus is not just a passive moon orbiting Saturn, It actively shapes its environment, feeding and maintaining an entire planetary ring. The plumes of Enceladus were a complete surprise to scientists. Cassini was not even designed to study them, yet as it flew past it became clear that this tiny moon was much more active than anyone expected. Cassini was equipped with an instrument called the Cosmic Dust Analyzer. Originally intended to measure dust particles around Saturn, it turned out to be perfect for sampling Enceladus's plumes. As Cassini flew through them, it detected not only water but also carbon dioxide, methane, nitrogen, and most intriguingly amino acids, the very building blocks of life. On Earth, amino acids are found in abundance around hydrothermal vents on the seafloor, where heat and chemistry create rich ecosystems. Could Enceladus have something similar happening beneath its ice? If so, it would make this little world one of the most promising places to search for extraterrestrial life. For a long time, some scientists thought Enceladus was simply water ice all the way through. But data from Cassini revealed that the moon's mass is greater than expected. This means there must be a dense rocky or metallic core hidden within. Enceladus is small, only about 500 kilometers across, and sits right on the edge of being rounded by its own gravity. Yet despite its size, it seems to have a differentiated structure, a rocky core, an ocean layer, and an icy crust. This rocky floor would be vital for supporting hydrothermal activity. Just as Earth's vents release heat and minerals from the crust, Enceladus's core could provide the nutrients needed for life to emerge and thrive. Cassini's close passes revealed more wonders. At the South Pole, the plumes align with giant fractures in the ice known as tiger stripes. Each is about 130 kilometers long, 2 kilometers wide, and half a kilometer deep. Unlike many icy moons, Enceladus has very few impact craters. In fact, the southern hemisphere appears almost completely smooth, which tells us that the surface there is geologically young. The constant recycling of material ice settling from plumes, tectonic shifts, and cryovolcanism keeps the surface renewed. In contrast, the northern hemisphere is older, dotted with craters and fewer fractures. The difference between the two poles shows us that Enceladus is still an active world, reshaping itself even today. Zooming in on Cassini's highest resolution images, we see a landscape resembling a frozen glacier with smooth plains of ice, broken by jagged ridges and folded terrain. It is alien, yet strangely familiar, like looking at Earth's polar regions through a distorted mirror. Sadly, Cassini's mission ended in 2017, and since then, we have had no spacecraft near Saturn. Enceladus continues to erupt into space, but for now no instruments are there to study it. Several mission proposals have been put forward, some to orbit Enceladus, others to fly through its plumes, and even a few daring concepts to drill through the ice. Unfortunately, all of these have either been cancelled or remain decades away from realization. The only confirmed upcoming mission to Saturn's system is Dragonfly, a drone designed to explore Titan. As exciting as that will be, it will not study Enceladus. For the moment, the moon must keep its secrets. But think about it. If we could one day send a probe into Enceladus's plumes, or even into its hidden ocean, we might finally answer one of humanity's biggest questions. Are we alone in the universe? Enceladus is a reminder that size is not everything. Barely 500 kilometers wide, it is a world of ice and water, yet it shapes Saturn's rings, hides an ocean beneath its surface, and may even harbour conditions suitable for life. It is one of the most mysterious places in our solar system, a frozen jewel with a living heart. For now, all we can do is watch from afar, piece together the data we already have, and wait for the day we return to explore it once again. So, what do you think? Could Enceladus be one of the best chances we have of finding life beyond Earth? The evidence points in tantalizing directions, but only future missions will reveal the truth. Until then, We'll keep looking outward because every moon, planet, and star tells a story, and together they bring us closer to understanding our place in the cosmos. If you enjoyed this journey, don't forget to like the video, subscribe to Cosmic Compass, and share it with others who love the mysteries of space as much as we do. Thanks for watching, and until next time, let's keep exploring the universe together.